Hey class, we're going to recap today's lab. The scenario that I gave to you is that you have these 5 unknown substances, and I put each of them in a beaker for you, labeled A through E. Those compounds were unknown, or I masked them using these names: Bliptor, Quindel, Zibrax, Snorpel, and Gravox. And the concept that you had to recall was that ionic compounds have the strongest attractions of the attractions that we've learned, and they're not intermolecular forces, so I put a little asterisk there. And then you have these things called intermolecular forces that are attractions between molecules, and we learned that hydrogen bonds are the strongest ones in general. And in order to have hydrogen bonds, you need a hydrogen covalently bonded to one of these small and very electronegative elements like fluorine or oxygen or nitrogen. And if you look on the board, I highlighted them for you in blue. So all of these are hydrogen bond opportunities. And so when you're looking at the structures of these molecules, you're thinking like Bliptor has the least intermolecular attraction, and Snorpel is going to have the most, because you just have many more opportunities of hydrogen bonding in between those 3 chemicals. And then we learned about some other ones like dipole, and there are other ones we didn't learn. And then finally have London dispersion forces, and they're primarily dependent on the size and the surface area of the molecule. But in our class, we emphasize size, and that's simply because if a molecule has more electrons, it has more dispersion forces. So you had to try to match these up using specifically 2 properties of these chemicals. One is melting point, and so that's going to be a proxy, melting point is, to figuring out, to give you an insight into what kind of intermolecular forces are going on. So high melting point is going to be something that has more hydrogen bonds, high melting point, because those molecules are harder to separate, so you're going to need more energy to separate them, hence a higher melting point. And things without, or things with fewer hydrogen bonds, or fewer dipole, and all of that, are going to have generally lower melting points. And the highest ones are going to be your highest melting points are going to be your ionic compounds. They're the ones that are not going to melt. Highest melting point, because those attractions are the strongest. All right, so I want to give you a little bit of insight, because I'm going to switch over to this video, which was just shot on the spot, because I happened to have a student stop by, and I had an extra hand, so I asked him to record me going through the lab that we did today. Hey class, I'm going to walk you through this lab we did today on intermolecular force. We're going to first start with the lid that's fairly smooth, so we get even heat distribution. This is just a random group that I'm just going on, and this one is group 10, so I'll just use theirs. I'm going to put this in order because I don't have a Sharpie or anything to label my lid. A, B, C, D, E. Okay. I got a clean spatula, and I'm just going to use a very, very small amount and transfer that. Just going clockwise. I'm going to start from that's, what do you call that? That's
Prong?
Prong, yeah. I picked up a friend on the way. All right, so that's all you need. Here is, now before I go into B, class, what should we do? We shouldn't contaminate. Like that down there. All right, so we got just a little speckle is all we need. That's going clockwise. There's B. All right. Now, wipe this down again. Pause. All right, so interruption there. Here's C. Just, that's it. Maybe that's a little too much, but kind of. Okay. Wipe. D. That's all we need. There we go. And then E. All right, now we're ready to light up this candle. point your lighter downward so the lighter fluid reaches Mr. Sparky. Come on. We want to center the flame so we get evenness. I'm going to lower this down. And let's get the camera onto the top of the lid. Get close up if you can. Boom, that's one. That's already done. That's E. Oh, where's my pencil? All right, E. I want to remember that. There's the second one. E, B. Can you help me out with this remembering part, Mr. Wally? E, B. And we're waiting for the third one to char or melt. All right, E, B was the order. All right, now we're going to lower this down. There it is. You see that, Mr. W? See it? Would you agree? Concur? Is that a little? Yeah, thumbs up. Okay. All right, so we got E, B, and A. Let me go to my board here. Write this down so I don't forget. Got it. E, B, and A. Melting point order. All right, next let's do the conductivity. Follow me, friends. All right, let's follow safety here. Hot stuff with these tongs. Blow that out. I got clean beakers. We're gonna add some distilled water. About the same in each one. About halfway up. All right, and we'll use this thing as our rinse, John. All right. None of it's labeled, that's okay, because we'll just put this stuff right here in front in order: A, B, C, D, E. Okay. Let's get about a pea size in here. A. Better use this side. B, C, D, E. Stir this up. Rinse. Stir. Not soluble. Undissolved. That's your non-polar. Non-polar doesn't mix with polar. Okay, you didn't have to know that. Let's get some new distilled water. Let's test our probe. Let's grab one of these guys. Okay. Let's turn this on. We want to go to micro Siemens, which is already there. Let's do it. Let's test it with the rinse water. It should be close to 0. It is. All right. Let's do A. Pretty much nothing. All right, nothing. Rinse that out. Nothing. B's nothing. A and B are nothing. 1,100. Pause. All right, so that was 1,100. See it again. Yep, 1,100, 1,100. All right, the rinse is still good. All right, let's go to, I can't see that. What does that say?
3,000.
3,000. All right, 1,000, 1,000, 3,000. All right. Last one. 100. Okay, so almost nothing. Let's turn this guy off. 0, 0. I forgot what this was.
That was the 1,000. That was the 3,000.
Okay, good. Thank you. Thanks, Wally. All right, so conductivity tests. We got A, B, C, D, E. A was almost nothing, close to zero, 1,000, 3,000, and this was close to zero. All right, so here's how we know what is what. First of all, since these are the five, can you back up a little bit? All right. So these are the five substances that you were given to match. We know the ones that conduct electricity conduct, must be the ionic compounds, which are Zybrax and Quindle. I discovered these this morning. All right. Now the one that conducted the most right here is going to be Zybrax. So that's going to be D. And the reason it's D is because if you look over here to the hint, the things with greater charge generally, and the ions that are larger, so I try to make that intentional with the 2 plus and the 2 negative, and I drew those ions bigger, they're not going to dissolve in water as easily. All right, so you need these guys to dissolve for the conductivity to be higher. So this here is D. And then C, because it's also ionic, we can expect, as long as it dissolves, it's going to conduct electricity. So this is going to be C. All right. Now let's use the melting point order to determine the remaining 3 substances. The thing that melts first is going to be the one that has the fewest number of hydrogen bond opportunities. This bliptor only has 1 area of hydrogen bond opportunity. So in other words, this is going to attract other bliptors less than Snorkel or Gravox, because they have many more hydrogen bonding opportunities. This is going to have the highest melting point. All right, so this is going to be A, because it melted last, or it melted third in this order of melting. And this is going to be B. All right, and this is going to be E. E melted first. Bliptor melted first. Gravox melted second. Snorkel melted third. Ionic compounds have the highest melting points. They're generally in the hundreds or thousands. So we use the electrical conductivity to distinguish between them. So I hope that helped. Okay, what do you think? What do you think, Wally? So here are the chemicals we actually used in class. If that makes you feel any better, these weren't toxic or poisonous things we were handling today. Sucrose is just table sugar. Sodium chloride is table salt. Starch was actually just cornstarch. And these other stuff are relatively non-hazardous. This is a long weekend, and I want you to enjoy it because we have midterms coming up next week. So here are the answers.